So we are going to take a couple minutes to look at the lesson from yesterday that should have been taught when I was absent, and then we're going to move on to today's lesson. The one yesterday was looking at this picture frame that was built with tiles. So if you look at your worksheet in front of you that says 512, writing equivalent expressions, I want you to write down your answer for letter A. Letter A says without talking to your teammates or counting every single tile, find the number of tiles in this frame mentally and think about how you can do this. So I'll give you a second here to find how many tiles there are in this picture. The correct answer for this one was 36. For letter C, it said that a lot of people would find that there were 40 tiles in this picture. Why do you think somebody at first glance would have thought that there were 40 tiles in this picture? I will give you a hint. This side has 10 and this side also has 10. So I want you to answer C. Why do you think somebody would have done 40? All right, we are going to flip to the back side to problem 513, and we are going to talk about some of the different methods that people use to solve this. So we are specifically going to focus today on Jonas and Alyssa's method. These seem to be the most two common that students like to use. So what Jonas does is he goes, okay, I have 4 10 by 10s here. So he's going to do 4 times 10, which is 40. But then he's going to minus 4 from these 4 corners. These 4 corners overlap. So we're going to subtract them out from the total. So for this one, you are going to take the 4 sides and you're going to multiply that by x, or however many is on each side, and then you're going to subtract the 4 corners. For Alyssa, what she did, I'll use a different color highlighter here, is she said, okay, this section is 9, here we have 9, here we have 9, and then here we have 9. So what she did is she did the total number of sides, which in this case was 10, minus 1, she's taking away that corner, and then multiplying it by 4 because there's those 4 side lengths. So these are the two different variables and formulas that we are going to look at for our lesson today, which is 513. So you can push this sheet to the side and then take out your packet that is labeled 513. For lesson 413, we are looking at how we can describe any figure. So we've already looked at describing a figure that has 10 on the side length. But what if we have a figure that has 8? What if we have a figure that has 20? What if we had a figure that has 1,000? How can we use variables almost as a shortcut to figure out how many total there are? I'm going to stop you here though, and I want you in your own words to describe what is a variable. A variable is the letter that we can use to represent an unknown number. You can use any letter. Two of the most common variables are going to be x and y, maybe z, but any letter works. For me personally, I try to stay away from the letter S just because my S's sometimes can look like a 5. So just be mindful of what variables you are choosing. So for 26, Bonnie is the owner of I've Been Framed Picture Framing Shop. What a great name. She's excited about the work that you have done. So use algebraic expressions to help Bonnie with each of the following orders. Be prepared to explain how you found each answer. So customer wants a frame that is 8 tiles along each side. How many tiles will Bonnie need for the whole frame? So again, I'm going to keep this posted from what we previously did. There are a couple ways you can figure this out. We could take the number of sides, in this case it's 4, times the amount that each side length is, so in this case it's 8, and then subtract the 4 corner pieces. So we could write that as 4 times x, because that could be any number of sides, minus 4. The other way that you could do it is to take 8 minus 1 times 4, or in this case, x minus 1 times 4. So using either of these variables, I want you to tell me how many tiles would there be in this picture frame. Your answer for this one should have been 28, regardless of what formula you use. There were 28 tiles, not 32. Okay, that's a common answer because people do 4 times 8, but don't forget about those corner ones that are going to overlap. For B, it says Bonnie's neighbor wants a frame that is 16 tiles long on each side. How many tiles will she need altogether? So I have listed for you the formulas you can use. Our x in this case is the tiles along each side, which is 16. So I would like you to find how many total tiles are there going to be in this frame. Your answer for this one should have been 60 tiles. You could have plugged in 16 here. 4 times 16 is 64. 64 minus those 4 corners is 60. The second one, x minus 1, and then times 4. So 16 minus 1 is 15, times 4 is 60. Okay, so this one has our lovely stoplight, which means that it is something that we should make sure we know how to do. So a new customer comes into Bonnie's shop and he says he wants a frame that is 25 tiles on each side. So this is what our x is going to be. He used the expression 4x minus 1 to calculate that he needed 99 tiles, but she explains that he actually only needs 96 tiles. What mistake did the customer make? So if we were to write this out, I want you to look at the multiple choice here. What mistake did he make to get the answer 99 instead of 96? What did he do wrong? For this one, he did 4 times 25 first and then subtracted the 1, but that is not what we should have done. We need to do parentheses first. So in this case, it would have been 4 times 24 to get 96 tiles. All right, so Bonnie's father had 32 tiles that he wants to use to frame an old photograph. He needs to know the dimensions of the frame so that he can have the photo printed in the correct size. So now we know the total tiles. We don't know how many there are along each side, and that's what we're trying to figure out. So we know our couple of formulas we can use. We could take 4 times x minus 4 and put that equal to 32, or we can do x minus 1 times 4 is equal to 32. So we'll go over this one together and then I'll have you try D by yourself. So whenever there's a variable, I like to put a box and we're trying to figure out what is that missing piece. So what minus 4 is 32? You were correct if you said 36. So then 4 times what is equal to 36? In this case, x would equal 9. If you solved it this way, with the blue, you would have had to figure out what times 4 is equal to 32, which in this case would be 8. So what minus 1 is equal to 8? My x would be 9. So using that strategy for this one, I want you to try to figure out how many tiles would be alongside for each for letter E. And I'll write out the formulas for you. So I want you to try to figure out what would those missing pieces have to be. And then see if you can figure out what x would be. How many tiles would there need to be on either side? For the first one, this missing box should have been 44. 4 times what is equal to 44? Your x would be 11. Over here, this one would have to be 10. So what minus 1 is equal to 10? Your x would be 11. We are going to skip 27 and 28, so please find problem 29. We're going to talk about algebraic expressions. So the process is called evaluating for an expression when you're trying to find a specific value. So for example, if you know that x equals 2 with this expression, you can calculate it by replacing the x with the number 2. Notice how they plugged it in with a parentheses. I would always do this because then you can tell that it's separate from the 3. It's not 32. So what if I said evaluate 5x if x equals 4? Multiple choice, would that be A, 54, or would that be B, 5 times 4? Which one of these would be accurate? Your answer would be B, 5 times 4. Remember, anytime you're plugging in for an x, I would recommend parentheses around it. Then you can always tell that they're separate and being multiplied. Your task now, I would like you to work on problems 29 and 30. You're going to check your answers, and then you're going to move on to your homework problems quietly, please, and thank you.